Okay, hey, welcome to a series of videos on organic chemistry. This course is an introduction to organic chemistry, and it's going to go over the basics you need for a first year organic chemistry courses in most curriculum, but this is specifically targeted for NCEA. Okay, so what is organic chemistry? Well, organic chemistry is the study of complex carbon compounds, except for carbon oxides and carbon carbonates. Um, Organic compounds are commonly found in all living things. That's where the word organic comes from living organisms. But it's also found in fuels like oil, coal, and gas, because those are all made from once living things as well. And it's these types of fuels, especially oil and gas, are used for the precursors or the starting materials to make lots of organic compounds that we have in our everyday life. So the special thing about carbon is it readily bonds to itself. So a carbon atom will join to other carbon atoms, and it will do so in a big long chain and in complex structures, not necessarily a train, but a tree-like structure. Now this ability to do this is called catenation. It can also bond to a variety of different atoms, and that gives the different organic molecules the properties that they have. So it can bond to hydrogens, oxygens, sulfurs, carbons, nitrogens, chlorines, fluorines, etc. The other special thing about carbons, as well as being able to bond to all of those atoms, is they will form 4 bonds. So there are 4 different bonding spaces, and it can make double bonds and triple bonds with themselves or other elements. So it can form millions and millions of different types of complex compounds. So let's just have a look at a few of these complex compounds. So an example here is dopamine. Now dopamine is called dopamine because it has this amine group on the end of it. Now this is a neurotransmitter. It regulates mood, motivation, reward, and influences like, do you find pleasure in things, focus, movement. If you have imbalances in this or not enough of this, it can lead to disorders like Parkinson's or addiction. So dopamine is really critical for cognitive function, emotion, and well-being. And it's important that we sometimes need to be able to understand how this works, or maybe make this molecule or other molecules like it to help people who have problems with their disorders to do with either too much or not enough dopamine. Caffeine. Here's an example of caffeine. Now, just when we look at these molecules here, actually each one of those intersections of lines is where a carbon atom is. Now you can see that there is a very complex structure of carbon atoms and nitrogens and oxygens here. Now this is caffeine. Now caffeine is a stimulant found in coffee, tea, Coke, energy drinks, and it blocks androgen receptors. So it focuses, it enhances focus and may cause insomnia, because caffeine is widely consumed throughout the world and it affects the central nervous center. Now, if we know that caffeine can do that, can be used as a stimulant to make people more attentive, then maybe we could make a molecule similar to caffeine and it would have similar results. So that's why it might be important to understand how this chemistry works. Okay, what about adrenaline? So this is also called epinephrine. Okay, this is a hormone that triggers the fight or flight response. So if you've ever been shocked, someone surprised you, and you get that burst of sort of alertness, that's the adrenaline being pumped from your adrenal gland into your blood. Now it's released during stress. It increases your heart rate, your blood flow, your energy, and it prepares the body for rapid action. Right? Now, interestingly, so if you compounds similar to adrenaline are put in EpiPens, so that when you have an allergic reaction that swells up your throat, you can take this fight or flight chemical, you can put an injection in there to increase your blood flow rate and energy and everything else to counteract the effect of your body to the, I guess, the effect of the swelling or your reaction to whatever it is you've been allergic to. So another chemical so these are all quite complex arrangements of carbons. But actually, all of these types of chemicals that either interact with our body or we use are really important, and there are thousands of types of them. And people who understand organic chemistry can understand how we might make these, change them, investigate them. Serotonin is the last one here. It's a neurotransmitter that stabilizes your mood, your sleep, your appetite, promotes happiness, calmness. If you have low serotonin levels, it can cause depression and anxiety. And it also regulates your digestion, and it can be influenced by diet and exercise. Now, if we know that someone has a low serotonin, then maybe we can give them something that is approximate to serotonin that will replace it, or we can give some serotonin, or we can try and identify problems by identifying the chemicals that are the reason for either there's too much or there's too less of them. And that's one important reason why we can do the study of organic chemistry, is so that we can unpack all of these types of chemicals that influence our world and our bodies. Okay, so in this video, we're going to look at the functional groups and how they might alter or change specific organic compounds. So here is a hydrocarbon, or a basic organic compound that's made up of carbon atoms joined to carbon atoms, with hydrogens filling all the extra bond spaces around the carbons. Now, in this molecule here, I've drawn carbon atoms with their selected bonds going to either the hydrogens or carbons. And in other places, what I've done is I've taken a carbon atom and I have condensed, or I've not shown all the bonds of the hydrogens, but I've just written hydrogen. So on the top at the left here, you can see here's a carbon showing the 3 hydrogens. On this bottom point here, here's the carbon, but I've just put H3. And if we ever see that, we assume that it is just this group here. Now this is an alkane, and this is called just a hydrocarbon because it is made up of just carbons and hydrogens. Now you can notice here that every carbon always forms 4 bonds, and actually every hydrogen just forms 1. So remember, on this carbon here, 1, 2, 3, 4 bonds. If we look at this condensed group at the bottom, this carbon has 3 bonds to 3 hydrogens, plus the bond that we can see to the carbon. It has 4 bonds as well. Anywhere that you see a carbon, it will have 4 bonds. And if you've ever drawn a molecule for an organic compound and the carbon doesn't have 4 bonds, you've made a mistake. Hydrogens always have 1 bond. Molecules that contain, just like I said, carbons and hydrogens are called hydrocarbons. Now, hydrocarbons in themselves have their own specific properties. They are insoluble in water. They can readily combust with oxygen to form carbon dioxide and water. But they usually don't have lots of specific organic properties in animals or plants or people. So what we can do is, if we take what is essentially a hydrocarbon and I replace a hydrogen or a CH3 or any part of it with a functional group, I can change the function or how this molecule works. Now here, there are 8 functional groups I've given, or if you assume that the 3 at the bottom are similar, 6 different functional groups. Now these functional groups are the common functional groups we have to be aware of in this introductory course, in this level 2 chemistry course. So we have carboxylic acids, alcohols, amines, alkenes, haloalkanes, which are chloroalkanes. We have bromoalkanes and fluoroalkanes. Now you can see here that I've drawn in the second column. You can see the second column here. Here is my carboxylic acid. It has a carbon with 2 bonds to an oxygen and an OH. An alcohol has a carbon that has an OH attached to it. An amine has an NH2. An alkene is a carbon-carbon double bond. An alkyne is a carbon-carbon triple bond. A haloalkane is this carbon joined to a halogen. Now, it's a chloroalkane if the halogen is chlorine. It's a bromoalkane if the halogen is a bromine, and a fluoroalkane if the halogen is a fluorine. So let's look at these molecules here. Can you identify the functional groups? Just take time and see if you can identify, using this table, the different functional groups that are in these different molecules that would change the original way that properties that they have, and they would work from the original hydrocarbon, but now we've swapped out functional groups. So if we look at this first molecule, we can see that there is a fluorine functional group, and that's the same as down the bottom. Here we can see the fluorine functional group, so this is a haloalkane. Okay, this molecule would now be classified as a haloalkane. The second molecule here, we can see that, or down the bottom here, we can see that it has a carbon double bond carbon functional group. So this is an alkene functional group. It also has another functional group in NH2, and this here is an amine functional group. If we go and look at this third molecule here, we can see it has an OH, and you can see here that an OH is an alcohol functional group. It has a chlorine. Here you can see a chlorine is a haloalkane functional group. Wait a sec. And we can see that there is a carboxylic acid group, the C double bond OOH, or sometimes just called COOH. So this molecule has 3 functional groups. Now in complex molecules, this is really quite common, but mostly when we do organic chemistry at this level, we'll just be looking at molecules that have 1 functional group, and as an exception, maybe 2. Okay, if we look at this last molecule, we can see there are 2 functional groups, this triple bond, carbon triple bond, which is an alkyne, and this haloalkane, another haloalkane functional group. So we have all of these different functional groups that we can identify in molecules. Now this is really important because the first skill that we're going to learn to do is identify functional groups and name molecules.
Hey, thanks for watching this video. Hopefully this has made you more confident with your chemistry. Don't forget to like, subscribe, or leave a comment about anything that you want to with this video or any questions you have. I'll see you later.